system. How research and engineering can lead us deeper into space. LOEB, Harvard University.
On the 9th of November 1989, I was a young postdoc at Princeton and a new immigrant to the US. The fall of the wall reflected my own experience at that time, as I was entering a new research field and a new culture around me.
The solar system is quite big. As you can see behind me, it stretches across thousands times the distance between the Earth and the Sun. That's where you get to the Kuiper Belt, but actually there is the Oort cloud that surrounds it at a scale of 100,000 times the Earth-Sun separation. And our Oort cloud touches potentially on the outer boundary of the nearest star. It's actually a star system, Alpha Centauri. It's 4 light years away. It takes 4 years for light to get from here to the nearest star. They haven't heard yet about the last elections in the United States. That was 2 years ago. The signal is going halfway. So they still have a very favorable opinion of our civilization. Now, Earth is our home. We love this blue marble, but it will not stay there forever. The sun is in the middle of its life, and actually within 1 billion years, all the oceans on Earth will boil off as the sun warms up. But before that, there is the risk of changing the climate, changing the environment that we live in, of a nuclear war. And we should simply contemplate moving somewhere else or exploring space more generally. Now, we might be also curious about the question of whether life exists elsewhere and where life is possible. And recently, we learned that about 1/4 of all the stars in the Milky Way galaxy have a planet like the Earth at the right distance from the star to have liquid water on its surface and the chemistry of life as we know it. And that's called the habitable zone around the star where liquid water may exist. And it obviously depends on the type of star. The star that we live next to, the sun, is not the typical star in the galaxy. The most common stars are low mass stars. And in fact, the nearest one to us is a low mass star. It's called Proxima Centauri. It's a member of the Alpha Centauri triple system. And it has 12% of the mass of the sun. It will live for trillions of years, much longer than the sun by a factor of almost 1,000. And it burns its fuel very slowly. So that's a good place to go to if you are worried that the sun will die. But is it really habitable? We would like to know. Maybe, is there life there? In fact, this star has a planet in the habitable zone next to it. It's called Proxima b. It was discovered just a couple of years ago. And this planet is tidally locked. It always shows the star the same face. So there is a permanent day side and a permanent night side, and it takes the planet 11 days to go around. So people, if there is a civilization there, they celebrate a birthday every 11 days. And my daughter said to me when I explained to her that there is a habitable planet there and that we might move there one day, she said, Daddy, I would like to have 2 homes there, one on the permanent night side where I can sleep, and the other one on the permanent sunset strip where I'll have my vacations. So we would like to know, is there life there? Is it possible to live there? And there are other stars nearby that have habitable planets around them. In fact, one of them is TRAPPIST-1. It has 7 planets, and 3 of them seem to be habitable. So how can we reach the stars? How can we leave the solar system, break the walls of the solar system, and go somewhere else? I was born in a small village in Israel, and I used to collect eggs every afternoon. I'm a very practical person, despite of what you might hear from other people. And as I grew up, I used to drive a tractor, and at some point I was interested. Circumstances brought me to physics, even though I was interested in, curious about philosophy early on. And then I ended up at Harvard University. I'm currently the chair of the astronomy department there. And one day, in 2015, I get a visit from Yuri Milner, who is an entrepreneur in Silicon Valley with a background in physics. He came to my office and said, would you be interested in leading a project to send a probe to the nearest star to find out if there is life there? And I said, of course, that sounds like a great challenge, but let me think about it for a few months to figure out if there is a technology that can do it for us. Turns out that both Yuri and I are at the same age, right now 56 years old, and in order for this to happen within our lifetime, we need to send the probe at 1/5 of the speed of light, 20% of the speed of light, so that it will get there within 20 years. I mean, within 20 years, I will be barely walking, but I will have gray hair, but I would like to see this come to fruition. And so how do you reach 1/5 of the speed of light, or a fraction of the speed of light? Obviously, if you are older, you might want even faster. The problem is that chemical rockets are limited. And that's true for any device that is carrying the fuel with it. You are limited to the amount of energy that is being released by the fuel per unit mass. That gives you the exhaust speed, and that limits your speed. So in fact, between Sputnik and New Horizons, the speed of the spacecraft did not change much. It was limited by the exhaust speed of chemical propellants. The idea that allows us, in principle, to reach the speed of light is that you don't need to carry the fuel with you. You can just have a sail that is being pushed by light. Just like the sail of a sailboat is being pushed by the wind, here we're using light that bounces off a sail to push it. This is called a light sail. And why can we contemplate it now? And by the way, I mentioned to Yuri after a few months that this is the only possibility to reach the speed of light. But I told him, it's just like getting married. You need one solution for your problem. You don't need more than that. And so the reason that we can contemplate it right now is because of Moore's law in laser technology that allows us to get high-power lasers within the foreseeable future by combining many small lasers. But moreover, there is the miniaturization of electronics. We see it in our cell phones. So if we want to have a spacecraft that carries a camera, a navigation device, a communication device, it doesn't need to be very heavy. If you take the guts of a cell phone, it can weigh only 1 gram. And so one can imagine having a sail, carrying the electronics with it that weighs roughly 1 gram, so it's very lightweight, and it's being pushed by a powerful laser. And that's the concept. But basically, there is a set of lasers on the ground that get combined to a very powerful laser beam, and they are focused on the sail that is roughly a few meters in size, that weighs roughly 1 gram, and the laser is about 100 gigawatt pushing on a 1-gram sail, roughly the amount of energy and power that was used to lift off the space shuttle, except it's given to 1 gram. And so that 1 gram reaches a fifth of the speed of light within a few minutes, at a distance of 5 times the distance to the moon, and that's it. Within 2 minutes, you reach a fifth of the speed of light, and then your spacecraft is on its way to the target, and it will take 20 years after these first few minutes to reach the target. There is a mother spacecraft that releases those sails above the atmosphere so that the friction will not slow it down, and then the beam is produced, pushing on this sail for a few minutes until it reaches a fifth of the speed of light. And then you can keep releasing more spacecrafts later on. The main cost is the infrastructure of the beamer. The cost of each spacecraft is minimal, roughly the cost of a cell phone. And then it takes 20 years for this spacecraft to reach Proxima Centauri, for example, getting close to the planet there, Proxima b, and taking photographs of this planet. And if we are lucky, it would look similar to the Earth. It will have vegetation, liquid water on the surface. And you might think that this is over, the story is over, but no, actually, once you take the photographs, it will take another 4 years for those signals to reach back the Earth. So you have to wait 4 more years. And this signal propagates at the fastest speed that we know exists in nature, the speed of light, but still it takes 4 years, and eventually reaches the Earth, and we can figure out what is going on that planet. So the challenge of actually targeting an Earth-sized planet at the distance of Proxima Centauri is similar to finding this marble at the distance of the moon, in the real sky, not this one. It's a great challenge. And there are many challenges to this project, starting with building the laser beam, the powerful laser beam, designing the sail such that it will be strong enough but lightweight, worrying about minimizing the damage to the sail from the impact of dust particles or atoms as it moves through the interstellar medium, communicating with this spacecraft. And finally, people tell me that policy issues are more difficult than physics. When you deal with people, you have to assure them that this, of course, this infrastructure will not be used for other purposes. And just to give you an example, when there is a dust particle that collides with a relativistic spacecraft that moves near the speed of light, it can create a crater, and one has to worry about it, but we figured out that the coating of just 1 millimeter thickness is sufficient to protect it. Now, the plans for this project are in the next 10 years to demonstrate the feasibility of the technology. That will be at a cost of around $100 million, to which Yuri Milner is committed. And then 10 years after that, if this is successful, building a prototype, and then that will cost 10 times more, and then eventually the final system will be constructed at 10 times the cost. The fundamental question is, are we alone? And it's quite possible that we don't hear any signals for a simple reason. Enrico Fermi, a famous physicist, about 100 years ago asked the question, where is everybody? And one possible answer is technological civilizations are short-lived. Technology evolves exponentially. It's an explosive process, and we know that. We see it these days. And so it's quite possible that technological civilizations destroy themselves soon after they develop advanced technologies, and they are short-lived. In which case, if we search the sky, we might find evidence for dead civilizations, some relic, debris, from them or some artifacts that they produce. Have we actually seen such a thing? Well, a year ago, the first visitor from outside the solar system was identified close to the Earth. It's called Oumuamua. And it's moving in an orbit that is a little bit peculiar. And we propose that it perhaps is a sail, a light sail. My hope is that once we break the walls of the solar system with a spacecraft, we will get a message back saying, "Welcome to the interstellar club." Thank you.